In 2014, director Christopher Nolan released one of his most famous films of all time, a science fiction adventure film called Interstellar. It also quickly became one of his most divisive films, however, with some audience members praising the film for its love versus nature theme that propagates throughout, while other audience members rejected the film for its dialogue and lack of subtlety. However, Interstellar became incredibly special for an entirely different reason. It managed to captivate the attention of the astrophysics community, more specifically for the scene of the wormhole that occurs in the last quarter of the film. In fact, this random science fiction Hollywood movie managed to radically change almost everything we knew about viewing and visualizing wormholes. But before we can talk about that, we have to discuss a few things. Obviously, first we have to look at Christopher Nolan, what kind of director he is, and what prompted him to make such a realistic film. Then we can talk about Kip Thorne, the theoretical physicist behind both the film and the wormhole visualization. And finally, we can talk about the scientific research paper that was published from this film, and how both of these changed astrophysics forever. So, without further ado, let's begin by taking a deep dive into the twisted yet hyper-realistic brain of one Christopher Nolan. Now, from the get-go, Nolan is incredibly different from most other directors, always emphasizing and intertwining his films with a sense of realism. Even his superhero films were impeccably realistic. According to Bradley J. Berzer, the president of the American Ideas Institute, when Nolan was writing his Batman trilogy, if something happened that could not be explained rationally, he, Nolan, excised even the idea of it. This philosophy bled into his supervillains as well. For example, the Joker in The Dark Knight isn't your typical supervillain with diabolical powers, but is instead described by Berzer as a master chessman, always planning and scheming, and always 3 or 4 moves ahead of his opponents. To add a little bit more comparison, let's take 2 other films that came out in 2008, the same year that Nolan released The Dark Knight: Iron Man and The Incredible Hulk. Both of these films managed to take the audience and submerge them in this ocean of a fantastical world, while Nolan, on the other hand, is too busy waterboarding the authenticity out of his superheroes. However, when it comes to the film itself, Nolan and his crew did run into a few roadblocks. For one, Nolan always emphasized getting as much footage as he could with no or to little CGI or computer-generated imagery. For example, take the 2010 thriller Inception, a film about literally going into someone's dream. In this film, Nolan had a scene where 2 people will be fighting in a hallway with twisted gravity. And according to Brian Abrams, the editor-in-chief for the Motion Pictures Association, Nolan actually required the construction of a colossal centrifuge. As you might imagine, Interstellar is no different, with Nolan pushing for getting as much as he could without CGI. Paul Franklin, the visual effects supervisor for Double Negative, the studio that worked on Interstellar, mentioned that the spaceship that they used, the Endurance, was actually realized through a combination of physical miniatures and full-scale models for the exterior shots. Even the robots were not CGI, but were physical puppets controlled on set by actor Bill Irwin. And therein lies the roadblock. See, Nolan wanted to make a film as realistic as possible, but he had no idea how he would film a wormhole. On top of that, for the sake of authenticity, he couldn't even take his lead actor, Matthew McConaughey, and smush him inside of a wormhole for the last scene. And that's where Kip Thorne comes in. Kip Thorne, like I mentioned earlier, is a theoretical physicist who, like many scientists at the time, heavily disagreed with the wormholes of Hollywood. Not to be confused with the wormhole that is Hollywood, but that's an entirely different speech. When Thorne first met Franklin, he mentioned that the popular conception of a wormhole being like a drain is completely inaccurate. It's more like a sphere, which is the most amazing way to say hello I have ever heard in my entire life. Both Thorne and Franklin began working together to take the physics that underpin a wormhole, convert that into a software that would then output an image. Now get ready for the most infuriating part of this entire scenario. The images that were rendered were only used because they looked amazing. See, Nolan and Franklin had no idea what they just stumbled upon, only using their images because, and I'm not joking, this is the actual quotation, they thought it looked really, really cool. Now, as frustrating as this might seem, it actually shouldn't come off as too surprising, since both Thorne and Nolan wanted to make Interstellar as realistic as possible. In an interview with Lee Billings, the senior editor for space and physics at Scientific American, Thorne mentions that the script was written from the ground up on the science to a very great extent. Thorne actually wrote a book called The Science of Interstellar, where he dissects the incredibly realistic approach used in the film. Now, but back to the future. When Thorne, Franklin, and Nolan realized what they just stumbled upon, they immediately began grabbing all of their research to compile it into one giant research paper to release to the world. This research paper, called Visualizing Interstellar's Wormhole, was published to the American Journal of Physics on the 20th of March, 2015, changing the common understanding of wormholes forever. See, not only did the research paper outline the visuals in the film, it also defined the educational opportunities of those visuals. One of those educational opportunities is to define how relativity concepts underlie the wormhole visualization seen in the film. Another educational opportunity is to explain the diagram for the 3-parameter wormhole that was used. Both of these talk about the science of the wormhole, but Thorne regards the latter section as the most important section since it showcases the true shape of the wormhole as Thorne first intended. In fact, the second section even tells you how you can make your very own wormhole simulation. The authors mention that by taking all the information from the research paper and shoving it into a software like Mathematica, Maple, or MATLAB, you can construct a light ray tracing map of one of the wormhole's 2 celestial spheres. If nothing else, this showcases how important this research paper truly is, since it gave scientists the first ever glimpse as to what a wormhole should even look like. Obviously, in 2019, we got the first ever photograph of a wormhole, but bear in mind that all of this research came out a solid 40 years before any of that technology was even conceived. As if that wasn't impressive enough, the research paper even lists amazing discoveries made by the film. One of the most awesome discoveries made in the film was the ability to construct images of what a camera would see when if near or inside a wormhole. Now, this is earth-shatteringly important to astrophysics because, as the authors put it, examining how light rays traveling backwards in time from a camera to a wormhole's 2 celestial spheres can be used to generate a map that can be used to produce images, not only of the wormhole itself, but of an object seen through or around it, allowing us to potentially get a glimpse as to what might lie inside of a wormhole. And it doesn't even stop there. In section 4 of the research paper, the authors list a multitude of formulas that were used in the film. But they also mention that these formulas, along with the lens distortion of a camera and the light refraction of light around the wormhole, can be used to generate a map that would give you the length, width, and height of one of the wormhole's 2 celestial spheres, allowing us to measure a wormhole by just taking a few photos of it. Now, a question might arise here, more specifically the question of how is this important to science? I've been going on and on about how important this research paper truly is, but what is that impact? And the answer is actually quite simple. This film marks the first time that a wormhole was rendered in a 3-dimensional environment. According to Adam Rogers, the senior correspondent for the Wired magazine, no one knew what a wormhole would even look like until they found out. Basically, scientists did have access to these 2-dimensional maps of the wormhole's gravitational fields, with different circles and different colors representing the fields and their various densities, but no one knew what a wormhole would actually look like in person. What's more impressive was that this visualization was purely done with mathematical calculations, meaning that this film is the first film in the entire history of humanity to show us what a wormhole would genuinely look like. This is the tedious and arduous process that Kip Thorne, Paul Franklin, and Christopher Nolan had to go through to make their film, and the monumental impact that their wormhole and research paper had on astrophysics. So the next time someone comes up to you and mentions in a passively aggressive voice that films are the scum of society, only successful as propaganda pieces for violence and mayhem, you can let them know that we can now take a selfie with the wormhole and create an accurate simulation to measure all of its dimensions, all because of a science fiction movie with robots that for some ungodly reason resemble a broken Lego.